Okay, so we're back. Try that one. Okay, so we're back to this. Let me go back here since nobody saw what I was just doing before. So we're going to look at this right here. So this is our to be labeled method of our 5 answers. So this is a 5 answer from a student. It's not as neat and clean using the ands and ors logic, but it's okay. We don't need that because they fulfill all the things. Does it check black squares at RC? Yes, free point right on line 1 there. Does it check the border above? Yes, it does with row minus, or that's column -1. And does it check the border to the left? Row -1, true or false. And then it returns the correct values based on that. So you don't need to use the fancy and ors. Simple else ifs works. Okay, that's still a 5 answer. Let's look at part B. Anybody coming back in here? Hey, we got one person back. Okay, so let's take a look at part B of the student response. Part B of the student response is this. So we got our free point here by creating puzzle, right? And we didn't say int new puzzle because puzzle was created, if we look back at the instructions, puzzle was created back at the beginning before the constructor ran. So puzzle's initialized with the beginning of the class, so we don't have to do that. So puzzle equals new square. We created of the correct size, free point. Access all locations of the puzzle without an index out of bounds error. Well, we have our nested for loops less than rows, less than columns. Columns is our length, and our puzzle of 0.length is correct. So we have our correct sizes. We won't have an index out of bounds error. Boom, we got that point. Calls to be labeled. Here it is right here. Our if is called to be labeled. Doesn't say if it is, to be labeled is on this line. It's called with the correct parameters. They use double equals true. Annoying, but free points, right? Creates and assigns new square to a location in the puzzle. So yes, it adds a square to a new location in the puzzle. Numbers identified squares consecutively in row, major order starting at 1. So we're starting at 1 with this int label here. And it looks like, yes, they are labeling squares using label and label ++. Works fine. On exit, all squares in the puzzle have correct color and number. And we know because this looks close enough to our model example that, yes, this will be correct logic. So out of the 1, 2, 3, 4, 5, 6 points in part B, only one of those points is actually about logic. So you can get 5 points here without actually answering the correct logic, just by doing basically what the question asks you to do, loop through it, call these methods, and place squares in the puzzle. If you don't get anything else right, you can get 5 out of those 6 points. If you did that basic stuff with this here, you would get 7 out of 9 points. That's at least a 4 without solving any logic. Let's look at our next student answer. So our next sample student answer. If R double equals 0 and C double equals 0, return true. So if black squares -1, R -1 and C equals true, or if black squares R and C -1 return true, else return false. Does this get this first free point? No, he never checks, or she never checks this information right here. Does it check for black squares of border and black squares right? Yes, it does. So that's 1 point there. Returns true. Square should be labeled with a positive number, false otherwise. So this is our logic point. Do we have correct logic? No. So we get 1 point out of 3 for this one. Next one. Oh boy, that's a bit of a mess. Int num equals 1. Did my stream just die again? Stream died again. I haven't stopped streaming. Hopefully this will all catch up. So on our student response here, let's see how many points we can give them. Puzzle equals new square, squares.length, and squares of 0.length. And that gets us our first point here. Accesses all locations in the puzzle and no out of bounds errors. So let's look here. Black squares.length, yep, and black squares.0.length. We shouldn't have any out of bounds exceptions. Less than or less than. Boom. 2 points. Calls to be labeled. Does he call to be labeled? No, they do not call to be labeled. We can't give him that point. Creates and assigns error in a location in the puzzle. Yes, it does create a new square in a location of the puzzle. Numbers identified squares consecutively in a row in major order starting at 1. Yes, it does do that. So it does use this, and it does label a square consecutively in order. And the last one, does it label all the squares correctly? No. So we lost a point here, and we lost a point here. So we got 1, 2, 3, 4 out of our 6 possible points. Plus our 1 is going to be 5 out of 9. Again, likely a 3 or 4 answer there. Let's go to the next one. If black squares are C, return false. Does it check black squares? First point. Awesome. Else if is C equals 0, or if black squares are and C minus 1, and if R0 or black squares R minus 1 of C equals 0, return true, else return false. So does it check the border above and to the right and to the left? Ooh, this is a tricky one. So let's think about what they're checking here. So if C equals 0, or if there's a black square to just above it, then that would give us, so if this is true or this is true, that would give us true on this side. All right, and it would also mean over here, one of these would have to be true. So this logic is not correct, right? Because this would not, let's take a look at our sample answer here, or our sample solution. We need ORs here, right? We need our ORs because it's not going to, it's one of those, right? So it's one of those. This is not going to work. Whoops, we need to go one more. Where are we? Right there. So this is not going to work. So this is not correct logic. We'd lose 1 point. 2 out of 3 on that. Or So this controls for out of bounds errors there. That controls for out of bounds errors here. Hold on. So this would say if both of these are true. Now see, because it's still this and. It controls for the out of bounds errors, but the and messes us up. Okay. Next one. We got a problem here. Declared a new square of this. We don't want to do this because it's already created above, so we have a problem. Don't get the point for this. Although, no, we don't get the point because it's local. Because we're saying square puzzle, on the stack, we would be above it, so it doesn't work. And it shows an inability to understand what's going on with the stack and local versus instance variables. So this would not get a point here. Int row, we get our 2 loops, and we go through puzzles without out of bounds exceptions. Good. +1. We check to be labeled, and we pass it appropriate parameters. Except not. Except we pass it a int here. This is not an appropriate parameter. So this would not get the points right here because they used RC here. That's not correct. It should be RC black squares, and that should be it. Puzzle RC equals new square. And it looks like, can't quite tell what they say there. So we do create that. So we get a point here. And puzzle equals new puzzle. And it doesn't look like they increment, so we don't get a point for this. So we get a free point for creates new this. And we get a point for that. So we get 3 out of 9 for this. My guess would be that's on the border of a 2 or 3. So sample 3A has an 8. Sample 3B got a 5. And sample 3C, which we just looked at, got a score of 3. So that gives you the breakdown of how they scored it. I highly recommend going through and looking at these in more detail. We're already at 50 minutes. So Casey asked me to go over arrays versus array lists and looking at some problems there. So I'm going to go ahead and go into that. And I had also had some other questions from other students about arrays versus array lists. So I highly recommend, again, going over question 4, which I have posted the student guides, student samples. They have the full explanations of why and what is going on with how they answered it and the details of that. So get your heads around what graders are going to be looking for. Okay, let's get into arrays and array lists. So I'm going to go to Coding Bat, and we're going to look at some problems. And before I do that, I actually, Rita had messaged me. Abbas has another, found it difficult to ask a question on the live stream because of network issues, which of course is not in our control. I want to ask... my Boolean expression matches up. I have an answer attached. Oh, let's see what Abbas had. Yes, Abbas. So it looks like your answer would be sufficient. And you have this extra thing here. So Abbas just sent me an answer that he tried to answer this with, and it looks like it would be sufficient. Just at first glance, I haven't looked completely through this, but I would say this is a 5 answer here. Okay, so I'd also gotten a question from Rita, sorry to call you out, Rita, here, about the difference between arrays and array lists. And I want to go through that really quick here before I bore you completely to death. I guess that's not going to format properly here. So let me just quickly go over those for those of you who still have a little bit of confusion about what the difference between arrays and array lists can be. So arrays are a data structure that can hold both primitive data, ints, booleans, and doubles are the ones that we care about on this AP exam, and objects like strings or other user-defined objects. Like we just saw in the last problem, it can hold things like a square class that you defined, or a puzzle class, or parking spaces in our parking garage problem, or data from our Seti problem. It can hold any of those. One of the key features of an array list, it is a fixed length. Okay, so as soon as you instantiate and create an array, it is that size for the life cycle of the array. Once the array is created, its length will not change until you destroy it and replace it with another one. If you destroy it, you also lose all of the data inside of it. This means that they're not very good at holding data that can change its amount a lot. Okay, so if you have something that is flexible in its amount of data, an array is probably not the thing for it. But they're very fast because they are so fixed in memory. They're also convenient when you know you have a fixed amount of data or position, and that's something I didn't add in here, or position matters. So if position matters in what you are going to work on, then arrays are your best friend. This is usually when you're doing math. So if you're doing, many of you have not taken linear algebra yet, but when you do something like linear algebra where the position of the data is important, is almost as important as the actual value there in your calculations, that's when arrays work. Array lists are way easier to use because they're objects that have methods attached to them. Think dot size. You can do your dot contains. You can do dot sort. You can do all of those things that we already have. But it's not built into Java, right? And that's why you have to use that import method or the import statement at the top of your program, right? And it can only hold objects. This is one of the key features. That's why ints have to be stored as integers. We have to use those wrapper classes, and sometimes we have to rely on boxing or auto boxing. The other main difference is array lists can change sizes at any time. In the background, they're actually arrays, and it just handles messing with those arrays for you, but functionally, they can change size at any time. So they can shrink or grow, and you can always add new objects, take them away, or insert objects into an array list, and it will shift everything for you. Arrays can't do that. When you try to add something to a position into an array, it's just going to overwrite that information there and not move anything for you. You'd have to do that manually. Array lists can shift data. Array lists are very handy for keeping track of objects, but they do have some drawbacks. Mainly they're slower, which we don't really care about in our class because we're not doing anything with large data sets, but they are slower. And they're not fixed, so keeping track of the position of items is more difficult. Not impossible, but more difficult. As a general rule of thumb, arrays are good for when you need to get to something specifically. So let's say I need to get to something at position 5, right? And I want position 5 to be something very specific, and I know that I'm going to be jumping to position 5, or I'm going to be jumping to another position, and I know that I need to be there. I know that my array has to be at least so big, and that I am certain about that fixed position. That's where arrays really come in. Array lists are really handy when it's something that you know you're going to have to continually search. They're really, really good for searching because they just hold whatever data you need. You create a simple for each loop, which you can always create a for each loop for an array list at any time, and search through the entire list, right? And that's where they're really handy. When you need to just search through an entire list pretty much every time, you need to sort that list frequently. Those are when array lists become important. All right, so that is our difference between arrays and array lists. Let's look at coding that and see if we can find some different ones. So these are array problems. Do they have an array list problem? Good question, Kenny. So Kenny's asking in the chat here, if we use array lists in our answer for AP, do we have to use the import statement? No, because you're not going to have access to the entire Java class, or like the way that they're going to structure it. You're not going to have that. You don't need to write an import for array lists, and you don't need to write an import for math. They are going to assume that you know what the import statement is, or that those are already imported. It's unlikely that you will have a question that requires a separate import that they don't specify. So they're gonna say, hey, we've imported math at the top, or we've imported array lists, or we've already declared array lists. This is already an array list data type that you need to manipulate. They're gonna tell you in the question, it's an array list, or they're gonna tell you that it's an array, or they're gonna tell you use the math.pow. They're going to let you know that you need to use that stuff. Okay, so let's see if I can find a question here. If anyone can see anything, I'll check my emails. I'll check comments on this. No one's replied to this. Okay. So let's see here if any of these are array lists. No. Again, arrays, 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 arrays. That's it. Let me go. If I remember correctly, the Seti. Let me go to Replit real quick. Was Seti? Is this actually a full Replit, or is this? Oh no, this is not it. Let's go to the assignment itself. So if I remember correctly, Seti does use an array list. Okay, so the Seti problem uses an array list. If you haven't done the Seti problem on Replit, go do it. And take a look at how we would do this. How we would do this is essentially we're going to need to loop through this array list of data packets. And remember our brackets here to define what the array list can hold. Remember, that's a thing we have to remember, that are part of the syntax of creating an array list are these brackets, and then telling it what kind of data it can hold in between those brackets. We're going to loop through that and use it in our data packet problem. It looks like a few people are still waiting for help on this, so I'll go ahead today and jump on passing those back to you so that you can work on the Seti assignment. These Replit assignments, I think, are honestly the best way to practice at this point. Between Seti, or between Replit and CodingBat, those are going to be your best two options in the next 24 hours to practice for the exam, and spend maybe another hour or so going through how they answer these questions, and or how they not just answer but grade these questions. You're not going to know what the rubric is. I have no idea what the rubric is for this year. So don't spend too much time obsessing about the rubric on this one. Just understand the key point is that when they tell you, hey, this is already working, right? And question 4 from 2016, this has an array list. So go through and see how they grade that. when they tell you to use something, when it's in this that code format, right? The monospaced typeface, it means it's most likely going to be something that you're gonna have to write in the question or in your answer. Figure out where on the page it needs to be written, and if you have no idea what to do, start looking for those default points. And those default points are going to be things like return statements. They're going to be things like creating a simple loop, even if you have no idea what the logic in that loop is going to be. It's going to be things like, creating or initializing things inside of a constructor. It's going to be calling methods that they mention. They're going to mention at least half of the methods you're going to need to use, right? String formatter dot total letters of words, it's going to tell you that that is something that we need to create. The list of strings, it already has the correct formatting there. All of this stuff is there for you to use. Use the hints in the question. All right, so we are just over an hour here. If there's any other questions else, I think that is all we're going to do for today. I don't want to completely bore you guys. Last thing I will say before I set you free here is, remember, I know it's stressful coming up to the AP exam here. And I know some of you have already taken AP exams. You've got more AP exams to go. Some of you have 2 tomorrow with a push in the morning and then this exam in the afternoon. Remember, you are not a single number from your AP exam. You are more than just a single digit. This will not define your life. This will not define everything about you in the least bit. It is a small piece of the puzzle that makes who you are. I want you all to do your best. I want you to study hard. I want you to prove what you know about Java to both the College Board and to yourself. But I also don't want you to stress out so much that it becomes an issue. I don't want this to be something that you take to heart too much. It's one exam. If you fail this exam, doesn't mean you can't become a rock star computer programmer. And it doesn't mean that it will ruin your life. There are lots and lots of factors about you that are not just this exam. We will have a short session really quick tomorrow at 10 o'clock for those of you not taking a push. Good luck on that if you are. And also, I just posted a quick video or a quick quiz in Canvas asking if you have received your e-ticket. Please make sure you check your emails and you have received your e-ticket. All right, everyone. Good luck tomorrow. If you don't hear from me, I wish you all of the best. We have just 1 week of assignments. After, we'll do something fun next week. Bye-bye, everyone.